Hey everyone, moving on with our integration techniques, we're actually going to examine exponential integration. So we have to kind of recall from differentiation, right? Where we have the derivative of any e to the power of fx would equals to, again, get back the original function, differentiate inside, so differentiate the power to give me back f prime x. In integration, is the opposite, right? So let's start with an example. Integrating e power of x dx. In differentiation, we differentiate the function and we get back the original function. As you can tell, right, efx, I still have efx at the end, therefore ex. In differentiation, we multiply by the derivative. In integration, we will divide by the derivative. So derivative of x is simply 1, so ex divided by 1 equals to ex. Well, I get back ex, so plus a constant c at the end. Don't forget about that. Moving on, another example, change it up a bit. E power minus 2y with respect to y. Similarly, I get back the original function, e power minus 2y. I divide by the derivative inside, so divide by minus 2, I get back minus e power minus 2y over 2 plus c. However, similar to our algebra, you are not allowed to introduce any new terms. Let's say I have e power x squared dx. You cannot just simply, okay lah, follow the same thing, right? E power x squared divide by 2x, right? Because it's a derivative. You just introduce a new variable term. Therefore, this will not result you as e power x squared over 2x. In fact, you can check your word. If you differentiate this, right, you will not get back this. All right, they are not equal. You can try it, all right? You won't get back the same answer. In fact, this is true for any integrals. As long as you've introduced a new variable, that answer is not your final integral. Let's look at another example actually. So let's say I have 2x plus 1 instead. Okay, so same thing here. You get back the original function, right? The derivative inside is 2. So I divide by 2 and add the other constant. So it actually doesn't matter. As long as the power is a linear function, linear algebraic function, or a constant, you would be able to get a final answer. So let's say where it's a constant, right? So e power of 2 dx. So e squared is a constant. My final answer would be e squared x plus c. So don't be confused, all right? Don't be confused just because it's a function on top. Exponential and a function on top is automatically f prime x e power fx. If don't forget that e is a constant, so if e power constant, so in this case e squared is a constant ultimately, and if you integrate a constant, it will give you back e squared x plus c. So this is just a note, all right, note. So in summary, we have exponential, right, of the form e power ax plus b dx would give us e power ax plus b, giving us back the original function, divide by the derivative, and finally adding the arbitrary constant plus c. So here, there we have it, integrals of exponentials of the form e to the power of ax plus b.